Good afternoon. We're now going to start the LACNOG session. During this session, we'll be having two presentations during the first hour, and as from 3 p.m. we'll be starting the peering tutorial, which is part of LACNOG's program. Today we have two special speakers for this afternoon. These are two speakers that I would like to introduce. The first speaker is a friend for many years now. I hadn't seen him for 27 years, and we met again here. This gentleman is the person who started to organize the technology workshops in Cuba. That was many years ago, and together we became involved in that effort. So for me, it's a pleasure to introduce Mr. Carlos Armas this afternoon, who will be giving us a presentation called RouteViews, Current Status and Practices in Global Observability. Let's give Carlos Armas a big round of applause. I have good news and bad news for you. First, the bad news. You'll have to bear with me for 30 minutes, and the good news is that Alejandro will be speaking after me, so don't leave. I'm Carlos Armas. I was born in Cuba. Half of my life I've been living in Canada, and I come here on behalf of NSRC, which is a non-profit organization based in on Oregon University. And my presentation will be dealing with a non-commercial tool, which is open source. So this is my commercial, RouteViews. And this is Autonomous Systems 6447. We're going to be speaking about this project that has been in place for a number of years. I'm not the person who knows more about this project. I'm probably the person who knows least about this project. If you have more profound questions, I will be happy to answer these. But there is a lot of information available that you can check. And of course, you can ask yourselves, and you can also help me as part of this group of NSRC. So let us start. So what is RouteViews? RouteViews is a project that began in 1995 with the intention of doing BGP routing analysis. At that time, in 1995, there was not a lot of information available globally. There were networks in different places, but the possibility of visualizing global routing and viewing information from different standpoints was something that was quite new and a major need for the people who were now beginning to work on routing projects. Right now, this is a global network with more than 40 collectors, 48 collectors to be precise. And these are strategically located. I apologize because my brain goes faster than my mouth and sometimes I stutter. But there are 48 collectors that are strategically located. What does strategically located mean? They are distributed in such a way that using my imagination, I stand anywhere in the world and I see the information on routing tables, and I can have the vision of that network containing BGP tables. Now, why is this useful? What is this useful for? I will explain this. This is a tool that is essential for two types of professionals: for network operators in real time or relatively real time, and for researchers looking for information regarding what has happened over time in order to publish papers or to study. Where is this located? The center is a project operated by NSRC, the organization I represent, at the University of Oregon. We have 48 active collectors distributed all over the world. We are located at traffic exchange points to provide the greatest visibility as possible from those connectors. There's coverage in all the regions, namely ARIN, APNIC, LACNIC, RIPE, NCC, and AFRINIC, all the regions representing the Internet organizations. And more recently, we have added some new collection points in Philippines, in Korea, and in Italy. This map, you can look this up at the website of the projects. So this map shows you the locations. Latin America and LACNIC is in the third place. We need to have more collectors, at least to come in second. Here you can see the visual representation then from where we can collect information in all those different places. I will be explaining the technology and architecture of this system now. When I refer to the architecture, I'm referring specifically to the collector we place in a given place at an IXP. This is the case of almost all of these. If you look at this here, over at this, there are only two collectors running. Those who are my age might recall Quagga. There are two Quagga collectors, but all the others are FRR. FR routing is a development that comes from Quagga. It is available and continued with the development of Quagga when this project stopped. And this is more than 95% of the collectors we have right now. The OS is the most recent one possible, 2404. We're now in the transition process from hardware to virtual machines. It's much easier to download a virtual machine compared to shipping equipment. The hard disk might break or disappear. And that doesn't happen with virtual machines. We have 50 terabytes storage of BGP data, historic data, since 1997. Villa was a young kid at that time. Tools and services. To access data, we can do this through a web interface, a modern web interface to do BGP queries. We can also do programmatic access through API. And of course, not all collectors are represented in API. The other way of accessing data is through Telnet and without a password, because all this is read-only information. You cannot write, and this is publicly available information. But in essence, what we are here for is to tell you to please use API whenever this is possible. If for whatever reason you cannot access via API, then use Telnet. But the intention is that we will be gradually migrating to API for everything and without Telnet. So you can also access through BMP with data flow via Kafka. We have 20 years of stored data, and you can access this information in real time. And we will explain this in a while. And you can also access historic information for the activities that are not urgent.
So practical applications. There are two practical applications that I call emergency or real time. And these are number one, detect hijacking and errors. So hijacking detection. Our client calls us and says that I cannot access service X. If you look up the information, what I'm reporting or what I want to be announced, whether my path has been hijacked by somebody with ill intentions, and the source autonomous system is not the one I want. I have a baseline. Someone called me up and said that my path was stolen. Well, that is an emergency. Another emergency could be what I'm announcing. I want to see what it looks like in different places. We've made a change and we want to check whether the change we made has any errors. So that is the principle for use, let's say in real time. The other type of use is academic research. There's no hurry, there's no urgency. You're working on a scientific article. And the other use case could be negotiation, peering negotiation. If I want to provide my clients the best possible service, I can assess where I could offer a better reach or less latency or delay to my clients. And I agree with somebody saying, well, we have a large traffic between our two autonomous systems. How about we do direct peering instead of jumping over another vendor? Or just very simply, in terms of costs, for cost assessment and be able to save money. So there is an ecosystem of different tools that have been developed over the course of the years. And a perfect case to mention is BGP Man, that doesn't exist anymore. I mean, these tools are not controlled by us. BGP Man, for example, was acquired by Cisco. And in other cases, a project that maybe people used in the past no longer works, or we could have tools that we are not familiar with and people are producing or using. There are many tools out there. So if you want to learn more about these tools, please go to our website and you will see the whole array of tools that are in use. So this is a type of story. So what are we working on right now? Right now, we are working on number one, trying to add more collectors to the global network. By adding new collectors, we have a policy or guidelines on how to collect and to see the type of requirements we need for connection. But in the next 2 years, we want to add 5 to 10 additional collectors. We are still in conversations. We don't know if they will all be finally available, but we want to increase to up to 10 collectors in the next 2 years. The other principle or project that we're working on is that of replacing the access to traditional telnet. We want RouteViews to be fully API and eliminating telnet. And that is another of our goals, the goals that we have for the next couple of years. And eventually, we also want to reinforce streaming. And what is very important is that we are working on the availability and security of the historical data that we have stored. We have information for the past, I would say, 27 years. We have two copies. We have two backups that are located in Oregon. Unfortunately, Oregon is in the Pacific Fire Belt, and we would like to store that data somewhere else just in case, knock on wood, something happens where we are located. In addition, we are automating using road principles, infrastructure management, and automating the infrastructure management. So we are speaking about peering policies. What are the requirements for our collaborators? Well, they're very well defined. First of all, it's a selective policy that is based on value added. That means that we are looking for collaborators in places where we don't have much visibility. It doesn't make sense to have many redundant collectors if our visibility of the network is the same. Therefore, what we are prioritizing is to have those that want to work with us and are located in a place where we have very low visibility. And that makes sense. We want to cover those locations where we're blind. We also want the equipment, we want the autonomous system to be public. It must be public, it cannot be private. And the equipment and the location need to be stable. Why? We don't want those collectors to appear and disappear. Sometimes it is better to have no information at all rather than bad information or information that is not available. So an unstable system won't give people, it's not trustworthy for people. So we want to have the more comprehensive view of the internet as possible, routing tables as complete as possible, so we don't need to go about in trying to implement collectors, many collectors in one place because they just have partial information. The peering DB as a mandatory database. So joining peering DB because it's auto pluggable. I'm not sure if that is the word. Of course, we don't want to allow entry to our network to people that have bad intentions. So entering peer DB is a way of ensuring that there's nobody that we don't know entering the collector system because we cannot allow the wolf in where we have all the sheep. And so if we provide bad information to the network with malicious purposes, well, that's not ideal. That's not what we want. And we don't want hobby networks. We don't want people like just joining a collector because they're running it from the house kitchen at home. We want to have a community where having a collector up and running assures that there will be a set number of years operation or a stable operation in the future. There are two modalities for connection that are very simple. The collector could peer with our network directly, direct peering, or multi-hop. That is not a problem. That could be negotiated. This is just for networks that do not have a mutual IXP or a shared IXP with the system. So these are the requirements for a collector. So these are the specifications of the virtual machine: 16 to 32 RAM, 100 gigabyte disk, and 4 virtual processors, 2 traffic interfaces, and around 10 megabyte per second. So it is able to collect without delaying the connection, and it's reliable. So again, desirable locations, regions where we have limited visibility, where we don't have eyes, locations where we are blind. Ideally, IXPs with over 100 peer agreements to be as visible as possible. And then unique or specialized environments. There are places where there might not be many clients, but there's a specific need. For example, it'd be interesting if there's a station called the Darwin Station in the Galapagos Island. It'd be interesting for us to have a collector here because there is a large scientific community in this location, and there's not a large internet population, and part of our work is to provide a support to scientific research, education, and efforts, and that is something that would be interesting as a specialized arena. So we have thousands of operators that query daily. They retrieve information, download information, and produce information as well. There are commercial products that depend on data. I just mentioned BGP MON, that used to be a relatively cheap service, and it is now become a Cisco product or part of a Cisco product, but they continue to collect this information. And the other impact is the amount of historical information that can be used for research. It is 27 years of information around the transition of the internet. So, what is our support model or funding model? Well, first of all, we are funded by the National Science Foundation, the US Foundation. We also collaborate very closely with CAIDA in the University of San Diego at the supercomputer computing center. We also receive donations from public and private organizations, and we also receive support from Google and other sponsors. So what can you do to help? Well, there are three things. Number one, we have a vision for growth. Number one, you can help establish collectors in places or locations that are attractive. That is the number one way you can help us. Second, every time that you write an article and you write an article about BGP routes, scientific research, please name us explicitly, because this is a way of us to show that the funds that we have received has produced added value, and the name, that DOI number for our project, that is how you can cite us or refer to us in your article, in your memoirs, in your book, and so on. Financial support. If you are using our service in a commercial product, we would appreciate it if part of the money that you are receiving, you can support us with some of that. So all donations are very much welcome. Collectors hostings in new locations, and any way you can help to keep the service up and running. So, for example, we need to install equipment in a rack in Montevideo, and I can say, well, I can do it voluntarily. That would be great. That is another way to support. What else? So these is our contact information, website, and I want to also thank the University of Oregon, NSRC, the Science Foundation, and everyone that has helped us keep this product up and running for so many years. If you have any questions, it I always say I don't charge anything. If you have a very difficult question, you have Hervey here in the room who you can ask.
¿Alguna pregunta para Carlos?
Any questions for Carlos? Hi, good afternoon. I have a question. I understand that the collectors you were referring to are local collectors. Is that so? At the IXPs. So my question is, what is the likelihood of those collectors having a remote session, a multi-hop session? Should these be locally collected, or can you consider a remote collection? Well, there are two ways to do so. You can connect with us in two different ways. There it is. You can connect with us. You can have a direct session, or you can do multi-hop. And so the answer is yes, you can. Yeah, the answer to your question is yes. Anyone else? Celsa? Over there. Hi, can you hear me? Hi, I'm Celsa Sanchez from NIC Chile. We host a collector, a RouteView collector, and we collaborate with a project, and we use the route collector data quite a lot in order to analyze the prefixes in Chile and to know what our PKI's dataset have. Yes, exactly that one over there. So adding on to what Jose was asking, we have a BGP session with the collector, but recently a large ISP from Chile got connected, which is Intel, and this is through a multi-hop session. So it works perfectly well. So very happy with that. I have also used the collector data to do RPKI studies in Intel, and I'm most grateful for all the work you do so that this continues to work and so that we also can use this for research purposes. Thank you. And if you didn't believe me, well, there you have the evidence. Any more questions? A third question over there. Your name and company. Good afternoon, Carlos Perez from NIC Costa Rica. Looking at the map, I think it's quite interesting to see that in Central America you don't have a route view. And I said Latin America. What's happening with Latin America? So I would like to propose, I think CRIX complies with the requirements you asked for, more than 100 peers. Maybe is there a necessity of putting a route view in Costa Rica, the CRIX? Get in touch with me before you leave, and we'll see how we can figure this out. Thank you. One last question, Jose Gregorio. I saw that you mentioned that you have statistics since 1995. One question. We are looking at the IPv6 penetration statistics following certain methodologies, about 50% globally in some countries. In some, it's more than 70%. Do you have statistics on the development of IPv6 in the sense of the ASNs that publish IPv6 prefixes, and whether these statistics are in line with these indicators that we have measured in a different way? Hi. Yes, but one of the things that happens is that IPv6 statistics began around in 2002, and IPv4 began in 1997. We have tried to find previous ones, but nobody has IPv6 statistics prior to that year from 1996 to 97. Now we're working on the dashboards again, and the idea is precisely this, to have statistics that we can share on the type of flow, for example, IPv6, IPv4, what the relation is and how much we're seeing. So right now we don't have this, but that is a great question, because I'm going to speak with a person in charge of preparing the dashboard, so we can also include this in the future and to make these publicly available as well. No more questions, so let's give Carlos an applause, and also Harvey Allen, who